Okay, so this is demo session number 2 for FARUK and his team. And in this demonstration, we're going to be introducing generator armature reaction. We're going to be explaining that generator armature reaction is negative work that is performed by electromagnetic field energy that is created at the subatomic level, and that energy can be created, and it's being created because if energy wasn't being created, the negative work that you're going to experience in a second would not even exist. Okay, and from there we're going to demonstrate the RegenX quantum motor and the RegenX generator that both harness the electromagnetic field energy and use that same energy to perform positive work. Okay? So the only difference between our innovation and what you're going to experience here is that we're using the energy that's created that's currently performing negative work, and we're using it in a novel way to perform positive work. That's it. Okay? So come on over here. I want to introduce you to generator armature reaction first. Okay? Because if you don't understand this, then it's pretty hard to move forward. Okay? So you are going to be the prime mover. Okay? So I'm going to get you to turn this generator in that direction. Okay? And I want you to keep it going. Keep it going. Now, you'll notice that it takes a certain amount of energy to turn this permanent magnet.
Yes.
This is a permanent magnet motor.
Okay.
And you're gonna make it run like a generator. Okay? So when current flows in the windings, when I connect this, current's going to flow.
Okay.
And you're going to experience generator armature reaction. You feel that?
Oh yeah. Wow.
Okay? Very soon. Come and try. Turn it and keep it going. Keep it going, keep it going, keep it going. It stalls, right? Okay, so Peter, I want you to do this one. Okay. Whoops. I want you to light this light bulb. Okay. You're Ontario Hydro, so you're going to turn it in. This one's easier to turn. Obviously, it's smaller. It's also a permanent magnet generator motor. Okay. Now light the light bulb. Okay.
Oh my God.
Come on, Peter, light the light bulb.
I love it. That's good.
You can't do it.
No, you can't do it.
Okay, you want to try it? Okay. Now I want to show you how much current is flowing from that sucker. You do it. Okay, Mary Sue, go for it.
Oh, good. Counterclockwise.
Yeah. Go the other way. Same thing. And look at the current. Keep going, keep turning. It's like nothing. It's like really like nothing. Now, what's happening when current flows in the windings, okay? Right now, there's, at the subatomic level, okay, there's electrons spinning and rotating around the atoms that make up the copper, okay?
Yes, sir.
Okay? Now, when you're turning this, you're inducing a voltage into the coils, okay? Nothing is happening, okay? You're inducing a voltage. A voltage is electromotive force, okay? So now, when I connect this, now what happens is I've created a closed circuit. That electromotive force causes the electrons that are spinning and rotating around the atom that make up the copper, okay? And the electrons bounce into each other because of the electromotive force, and they cause the electrons to migrate down the wire through the whole circuit, okay? And when an electron is spinning and rotating around the nucleus of the atom, they're rotating and spinning, and they're creating, in their rotation and spin, an electromagnetic field around them, okay? And the chances are, the electromagnetic field that's created by the spinning and rotating electron, keeps the electron in its orbit, okay? Now, when the electrons migrate down the wire, those electrons, which are in the wire right now, which are essentially dormant, okay? They're not producing an electromagnetic field around the wire. When they move through the wire, because the electrons are moving, that magnetic field becomes externalized, okay, around the wire, and that's why we can measure it with this meter, which reads, this meter reads the electromagnetic field around the wire, and Jonathan, you can shut the door there. Reads the electromagnetic field, and converts it to current. Okay, that's how it works. So,
Lovely, thank you.
the electromagnetic field that exists at the subatomic level, the electron level, right now it's dormant, it's there, but it's not doing anything. As soon as current flows in the windings, now it's externalized. That electromagnetic field energy that is either being constantly created or has always existed from the Big Bang, now becomes externalized, and now it performs negative work. And it causes a reduction in the kinetic energy of the spinning of the system. And you feel it, okay? There's no doubt about it.
Yeah.
You both felt it. So, if you're spinning this in the counterclockwise direction, the counter torque that's produced inside the generator is trying to turn the energy that's created, the electromagnetic field energy, is performing negative work in the opposite direction that you're trying to turn. If you turned it in the other direction, you get the same effect. Our innovation, okay, it's very simple. It delays the flow of current in the time domain, okay? That's the essence of what it does. And in doing that, it delays the production of the magnetic field. So now, because the rotating magnetic field is still rotating, the production of the magnetic field, instead of resisting the rotation, assists the rotation. Okay? It's like if you were coming at me, okay, I would push you back, okay, and if you're going past me, I would try to resist your moving past. Now, if I delayed that's generator armature reaction in a nutshell. If I delayed my reaction and you came at me, and I delayed and I waited until you're here, and I pushed you, now I'm accelerating your departure. That's it. That's all you have to understand. Delay your reaction, save your energy. It's a martial arts thing.
It is.
And anyways, it's a martial arts thing. It's one of the key. Why waste your energy trying to oppose an opponent when you can use his energy? This is the essence of what we're doing. Now, we're using the energy in the generator. We're using the energy in the motor. Okay? same energy, the only difference is delayed in the time domain, okay? And I think what I'll do is I'll show you this, just so you can see it on the oscilloscope, and then we'll jump into the motor generator, and we'll almost be done. Okay, so I'm going to show you the same thing we showed FARUK, because it's important that you get this. Okay, it's like, this is the fundamental. So, here we have a motor. An electric motor that's turning another electric motor. This is the prime mover, okay? Like you were. And this is the other motor, okay? This is a simulation of what you're going to see here. Okay. And what you're seeing here, okay? Now, according to all the laws of physics, everywhere, you cannot, number one, you cannot make this motor go faster unless you increase the energy field. You cannot, the universe is playing a trick on me here. You can't make this motor go faster than it's going right now, which is nothing, unless you put energy into it, electrical energy, okay? You can't, if it's spinning at a certain speed, you can't make it go faster without putting energy into it, and you can't make it go slower unless you put energy into it. Okay? Unless you put some kind of drag or force on the drive shaft to make it slow down. Okay? That's negative work. That's a form of negative work. And the amount of force that you put on the drive shaft to make it slow down, if you looked at the amount of force that you put and the amount that it slows down, you get the exact amount of work that you're performing. Okay? Now, if you make the system accelerate by the same amount, same RPM, now you're performing positive work. Okay? That's the first critical thing. You can't make the system accelerate without increasing the input energy. Okay? Number two, you cannot use that motor, which is not receiving any electric input power, to accelerate this motor. It is impossible. It is, as I said, the first statement is completely impossible. The second one is on a scale of impossibility. That's even more impossible. Okay? In order to make this motor go faster, you have to put some energy into it. Okay? So, what we're going to show you is that is indeed possible if this motor is a Regenex motor. And I'm going to show it to you. I'm going to show you that is now possible in this prototype, and this prototype. We might not get it all on camera, but this is exactly what we're doing. And we're using the same energy that you experienced here. The only thing we're doing is delaying it in the time domain, and you're going to see that on the oscilloscope. Okay? All right. So, so if you guys want to come around where this is, just so you can watch the meters, and I'll run back and forth. So, what we're gonna do, first thing we're gonna do, when you guys were spinning this at a steady state speed when it was on no load, okay? You were, steady state speed means constant speed, okay? You were spinning the system at rotational equilibrium, okay? Rotational equilibrium means that it's neither accelerating nor decelerating. It's rotating at a steady state speed. This drive shaft right here is at static equilibrium, okay? When it's rotating at a certain speed, it's at rotational equilibrium or dynamic equilibrium, okay? The power in this drive, the torque and the power in this drive shaft is the torque times the speed, okay? Right now the speed is 0, the torque is 0, the power is 0. There's no ability for this drive shaft to perform any work, okay? Cannot be done. When it's spinning at a steady state speed, rotational equilibrium, there is the net torque in the drive shaft is 0 because it's not, if the torque, if the torque is a positive number, it's accelerating until you run out of torque. If the torque in the drive shaft is negative, it's decelerating. Very important to understand. So what we do is we bring the system up to rotational equilibrium. That's the first thing. From there, a drive shaft that's at rotational equilibrium has no ability to do any additional work. It's like when it's like putting your car in cruise control, okay, and thinking that you can go up a hill without the car needing more gas. It will not happen. It'll go up the hill a little bit and it will stop. If it does, the motor doesn't get more gas. Okay. So what we're going to do is we're going to demonstrate. In this prototype, there's a conventional generator coil. This is a teaching tool. Okay. And in this prototype, we have a conventional coil that powers this light bulb, and we have 2 Regenex coils wound on the same core, okay? So they're being influenced by the rotating magnetic field at the same time, okay? Very important. And the loads are exactly the same. All the conditions are exactly the same. We're going to show generator armature reaction, EV regenerative braking, yada yada yada, negative work being performed by electromagnetic field energy that's created at the subatomic electron level. Okay, we're going to see the system decelerate, and then we're going to put the Regenex coil on, and we're going to see the system accelerate. Okay, we're going to see this same coin, but 2 sides of the same coin. Okay, we're going to see negative work being performed and positive work being performed with the same energy. We're not like pumping electrons, we're not doing any weird stuff. Okay, so one more thing. We're going to be delivering about 10 watts to this load. Okay, this meter is showing us how much energy it requires for our prime mover, just like you were, shows us exactly how much energy is required to establish rotational equilibrium, okay? Depending on the conditions, it's going to take more or less, okay? And so I'm going to try to put it at about 150 watts, okay? At 150 watts, our drive shaft going from our prime mover here to our generator, there's the power and the torque in the drive shaft is 0. The power in the drive shaft is also 0. There's no energy in the drive shaft in order to do the work required to light the light bulb. When the light bulb goes on, the generator is going to perform negative work. And you're going to see that because this is like cruise control in your car. As soon as additional work is being performed, the input energy is going to go up, okay? And this number is going to go up by about 20 watts, while we generate about 10, okay? That's normal generator operation. When we put the Regenex generator on, the speed's going to go up, and this number is going to go down, okay? The number is going to go down to below what was required in order to establish rotational equilibrium. Meaning that if we had 0 mechanical watts in our drive shaft at idle, and that number goes down, there's less than 0 watts in the drive shaft, okay? And it's going to be super obvious, okay? It's like, it's the most, and then I'll show you the, I'm going to show you the load current sine wave for the conventional coil, the load current sine wave for the Regenex coil, and you'll see that one is delayed in the time domain. That's all you need to know about everything in here. Okay, so we're at a rotational equilibrium. Our prime mover requires 160 watts to establish rotational equilibrium. The mechanical power being delivered from our prime mover to our generator, the mechanical power in the drive shaft is 0 watts. And I'm going to put the conventional coil on load, and you're going to experience generator armature. You're going to witness. So, the prime mover is slowing down.
That's going up.
The input has gone up by 20 watts. Mathematically, we're delivering about 10 watts to the load. Okay? This is normal generator operation. This is regenerative braking in an EV. And this is the load current sine wave for the conventional coil. Okay? Now I'm going to put the Regenex coil on load. And I'm going to take this off. We already know, but.
So that should drop to 160 again.
So we're at 160. And it goes up to 180, okay? So we're delivering 10.95 volts to the load. I'm just saying this for the camera. At 0.88 amps, okay? And you know how much work is required. You weren't delivering any amps, like, okay? So it takes a lot of work to deliver 0.88 amps, okay? This number is going to go up. The speed, this number is going to go down, and the speed is going to go up, okay? This number has gone up. We're delivering more power to the load. Okay? The speed has gone up. You have a tachometer there. You want to work the tachometer? Do you care? You can tell us. Run around here. You can be our tach guy. So you just put that on there. So 34,
RPMs.
3,488 RPM, okay?
Okay.
Now we'll put it into conventional mode just so we can confirm. So tell us what it is. Yeah, you stick it on, there you go. What's the speed?
About 30 feet.
Now, you need to tell us exactly what it is,
3488.
okay? Okay? Is that real?
Yes. Alright.
Yeah, good. 34. Okay. So now we're going to want to know what it is when I put the conventional on. The 3488. It goes down to 34.
3460.
Yeah.
59.
Okay. So now you're going to tell us what it is when I put the other
Yeah.
one on. Thirty-five oh one.
Nothing trouble. 3506.
3506.
Yeah.
Okay. And
That's gone down.
it's gone down, it's 3 watts less than 0 watts in the drive shaft. Okay? This is the